Before we go into any history of how this ended up being something I was doing at all, just a real quick peek into some of the really neat graphs that come out when you look at a sequence such as the Fibonacci sequence or its related sequences. In this case, we have a graph of the Fibonacci sequence over a modulus of 3. And notice this is one of those trailing off the screen type graphs. That right there in blue is the motif of the same graph. It just repeats that shape over and over again. And yet, in doing so, ends up trailing off the screen. Here we have another one of those, this sort of open graph, if you will, in the sense of not closed. This is the Fibonacci Mod 4 in blue, which is this one right over there. And notice, actually, the Lucas sequence, if you're familiar with Fibonacci, if not, I'll mention it a little bit. But it's basically like the Fibonacci sequence. Also in Mod 4, and quite interestingly, it does a very similar thing, only it's going off this way. So, kind of amazing stuff that's happening. The sort of thing that you'll appreciate more as you look into these graphs. Not all graphs do that when you just change their terms a bit. Of course, the Fibonacci graph has always been special in every sort of way you can imagine, it would seem. This is the same sequence, Mod 5. This is Fibonacci Mod 5 in blue, and notice that's closed. So just showing this one to show it's not always exactly the same, because this is the same Lucas sequence, similar to the Fibonacci sequence, same Mod 5, but now notice the Lucas sequence in white is trailing off the screen here. It's an open graph, whereas the Fibonacci sequence in blue is closed. And so it just repeats that graph over and over again. Now here we have the Fibonacci sequence Mod 6, rather beautiful looking shape going off toward infinity. Now this one is the Fibonacci Mod 6 in blue. There's a bit of overlap, so pardon that, but this is a Lucas Mod 6 as well in white. And notice they're very similar graphs, except they're just in a slightly different location. And possibly other things there, but it's noticeably similar. And then, so many fascinating things happen when you start exploring these modular residue sequence graphing systems, MRSGSs. And so, it just kind of had to look more deeply into it, and next thing you know, there's a monograph coming out of it. Now, here's the Fibonacci Mod 7, just going off the screen in this rather meandering sort of way, almost a glide symmetric type looking thing. And now here we have the Fibonacci Mod 8. And this is the Fibonacci sequence Mod 10. The remainders when graphed in the absolute system, absolute MRSGSs. Again, we'll get to that. This is the Fibonacci Mod 14. All right. And here is Mod 15. Take a moment to appreciate this. This here is an example of a closed graph. The Fibonacci sequence repeats this shape over and over again as it goes through its terms. In this case, in a modulus of 15, and it just does so over and over and over again. And yet it's not symmetric. There's no rotational symmetry here. There's no reflectional symmetry. It's just sort of this odd-looking shape that is nonetheless closed, and that's what the Fibonacci sequence does in Mod 15. That is a graph of the Fibonacci sequence, Mod 15. And here we have this wonderful sort of flip-flopping thing again with Mod 17. And this is Mod 19. And again, totally asymmetric graph. This is the Fibonacci sequence Mod 20. And a little more complex here going off the screen, Mod 22. And here we have Mod 23. And now another closed graph, which has that sort of symmetry down the middle here. Right, so it's still bilaterally symmetric. Part of my axis is a little crooked here. But yeah, it's bilateral symmetry, and yet it's a rather peculiar shape in it. And here we have this Fibonacci Mod 26. And I just love this one. This is Fibonacci Sequence, modulo 50. So the modulus is 50, and as in 50. And I like this one so much, I had to see it in this nicely sort of embossed looking variation here. It's just a simple accentuation of the lines and segments that are featured in this graph. Just amazing. It's got that bilateral symmetry again, symmetric down its middle area. And yet this, I don't know, it's just nice. Yeah. Okay, and then here's a mod 75. This is also a peculiar, not symmetric, closed graph that the Fibonacci sequence repeats over and over again when it undergoes a modulus of 75 and one of these MRSGSs. Again, closed but not symmetric. Closed but not symmetric. This is mod 360. Same Fibonacci. This is mod 512. Closed, complicated, and not symmetric. And this one trails off the screen, repeating that same shape over and over again, flip-flopping this way and that way, over and over again off toward infinity. That's mod 523. Again, we have the Fibonacci sequence. Now, this is a closed, asymmetric graph, rather complex, rather intriguing. Again, closed. This is mod 1440. It's closed. It repeats that over and over again, and yet it's not quite symmetric if you look at it. And here we have this is 4,880 is the modulus. This is again the Fibonacci sequence graphed within that modulus within the an MRSGS system. In this case, it's a relative MRSGS system. Okay, now we're just kind of going off. We higher moduli. This one doesn't even fit on the screen too well here. Could magnify, could do other things, but here we have a Fibonacci-like sequence, which is just similar to the Fibonacci sequence with starting seeds that are different. I'll give a little thing on the Fibonacci sequence in a bit. But here we have basically starting with 1 and 4. So 1 plus 4 is 5, 5 plus 4 is 9. This is modulus 50. Notice the bilateral symmetry again. And yeah, so that gives you a little bit of a taste of what the Fibonacci and Fibonacci-like sequences look like within these MRSGSs, or modular residue sequence graphing systems.